Question 6. Let's get straight into it without any of those huge intros to go. Okay, what are we trying to do here? Trying to make sense of all of these. This sketch below shows the graphs of g of x equals k over x minus p plus q. What type of function is g of x? I'd call that a hyperbola, right? Because we got that x in the denominator. What about this function f of x? What type of function is f of x? Well, it's got the x, the variable, and the exponent, so exponential. So we've got a hyperbola exponential. Now, they're actually kind enough to tell us which one's which, but otherwise this one's f definitely can be useful. Get your highlight out, highlight that one so you know which one's which, and the hyperbolas, this one here, and you could draw it neatly in like I have. Okay, so this can be quite useful and you've just orientated yourself already. Cool. Hyperbolas and exponentials. They've got asymptotes, right? What is an asymptote? Well, an asymptote is a line that your function gets closer and closer and closer to. So they've told us a few bits of information. Okay, let's see what they've told us. Y equals minus 2 is an asymptote for both of these functions. So y equals minus 2, there it is, dotted line, it's getting closer and closer to those. So that's going to be useful information. G of x has a second asymptote. Okay, we kind of expected there to be another asymptote. So there we go, there's an asymptote there. So that's that bit of information. This bit of information. Graphs intersect at 2, 6. Okay, so that's this point over here must be special. They both intersect there. And this one passes through the origin. So it looks like it passes through the origin, but they've told us as well. Otherwise, maybe it was at minus 0,001. They've told us that that point there is the origin, 0, 0. So all the bits of information from there on here, and it looks like point E is going to be useful for a later question. Determine the axis of symmetry with a negative gradient for g of x. Okay, so for this question, what are we thinking? What's kind of, you got an axis of symmetry. What type of function will the axis of symmetry be? Well, I'd say it's a straight line. So we already know that it's going to look like y equals mx plus c. It's going to sit on our diagram like that. Right, that very straight wonky line there. What's the gradient of the negative axis of symmetry? Well, it's always -1. Looks like -1 and it is. So that's -1. What point does it pass through? It passes through this point here, and we know the coordinates of that point are 1 and -2. So you've got that, you know what the gradient is, and you know that you can just sub that point in, because we did a previous question where you found out the equation of a straight line. So really a bit of a gift once you know that y equals mx plus c and m is -1. Okay, basically find the equations of the graphs given. So for our graphs, and I'm just going to ask it in this way, what does P do to the graph? Well, P moves the graph or translates it or shifts it left and right. Okay, so that's going to help us, and the asymptotes can help us there. What does Q do to our graph? Well, Q is the vertical translation or shift, so it's moving it up and down. So all we need to do is look at the asymptotes for P and Q. If we've got everything except one thing in an equation, what was our method of attack for this once we knew that y equals minus x plus c? That's not great. Minus x plus c. What did we do so that we could find the value of c? Well, we subbed. So once we have p and q, to find the last variable, we can just substitute a point that is on the function. So try and find a point on the hyperbola, which I've highlighted in yellow, and substitute it in. Okay. Here we've got a, b, and an n? Well, the n's easy, right? What does this plus n do to our function? Translates up, down. Okay, because that's what that plus at the end. Look, it was plus q over here. Yeah, it's plus n. Doesn't matter the variable's name. What does a do to our function in this case? Well, it's multiplying it, so it's kind of stretching it. Okay, and what about b? Is b going to be a fraction? So is it going to be like a half, or is it going to be a whole number like 2? How do we know which one does which? If you've got an exponential function, which one looks like that, going exponentially, and which one looks like that? Well, this guy here is it's going up exponentially, so this is like 2 to the x, whereas this one here is like a half to the x. I always use 2, it's like the smallest prime number we've got. So 2 to the x goes up, half to the x goes down. What about this? Is our a value going to be positive or negative for this function here? Well, if it's positive, so let's have a look at this and just compare that. If it's positive, there it is. There's 1, let's say, times 2 to the x. But if we looked at something, so that's 1 times 2 to the x, what happens if we said minus 1 times 2 to the x? Well, what does the negative do? Like, think of parabolas. What does the negative do? Well, it reflects it about the y-axis. So instead of going like this, it's going to say now our graph were like that. Then we're going to take it and we're going to say, no, well, let's reflect it and let's do that. So see how it's going to be going down. So the same with this one. If this one were to reflect, if this were negative, then it would reflect and go like that. So those are the types of things we're thinking of what to expect. Now, if you're ever given the 0, you're going to substitute in. So just sub in those values and you'll get that. ED is a line parallel to the y-axis with the point E, blah, 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 blah. So OE is 2 units. So all we're given extra information is that this distance here is 2 units. Therefore, what are the coordinates of E? Well, the y value is 0, right? Because it's on the axis, on the x-axis. And if that's 2, then it must be negative 2. So therefore, what do we know about points C and D? Well, we know that their x values must be negative 2. So C is negative 2 something, I don't know what. And D is negative 2 something, don't know what. If you're given the input, if you're given the x value, how do you find the output of your function? Just sub it in. You've got your formulae for these functions, sub in that, you'll get a value for that, whatever it is. This you'll sub into the hyperbola, you'll get an output. Whatever these two numbers are, you can just find the difference to find out what this length is. Right? You know, if you're given 2 points, let's give them positive values. If this is like 7 and that's 2, well then your distance here must have just been 5 because you're going 7 minus 2. So easy enough once you know how, of course. So I use that phrase sometimes, but I think if you've got to this point, then you look back and go, it's easy enough. But how do we get there? And that is the heart of this, to go, what are we told? Okay, so just pause, take some time. If that distance is 2, okay, well that means that that's x is negative 2, that x must also be negative 2, that x must be negative 2. That's our thinking, oh, well, if you give me the input, I can find the output of a function. Oh, so I can find out that y value, which would be there, that y value. Oh, so what am I working out? The length. Oh yeah, well, I know that concept you do have. We've been using it for how often? If I said, what's 7 minus 2? In some ways you might have been thinking, well, 7 minus 2, what's the length between 2 and 7? It's 5. So this length, same idea. So just subtract them. Okay, so trying to reinforce that although there feels like there might be a lot going on here, just take it step by step. Hey, 5 marks it's nice because it's almost saying, well, we found these ones, we slogged through our algebra and did them a bit quicker, so we had a bit of time here. That's what I want to reinforce with the marks a little bit, is give yourself time where you can just to go, what is it asking? So that's 2, so that's -2. Okay, cool. That was like 10-15 seconds to just get on top of what the question's asking, which you can definitely afford yourself. Okay, that's that for now. Not so much gift marks anymore, huh? Well, some of them are gifts. Come on. But yeah, we have to think a little bit more.